Assalamualaikum and very good morning to Dr. Nasratul. My name is Nick Faris Ikwan and my ID number is KA20127. And today with me is Tanes Bengades, number ID KA20014. We are from Group 3 from Section 1 and we will present to you about our project. So for the introduction, this project is to design a process capable of transforming steel mill industry flue gas into ethanol through gas fermentation. In this study, we focus on the airlift reactor, which is R101, is the where is the process of fermentation occur. For this study, we use two methods to identify hazard and risk that possible will happen during the process, which is hazard table and fault tree analysis. For the hazard is created to identify and evaluate any problem within the airlift reactor that could poses a risk to the bacteria, since it is the main product for the fermentation. And then for the fault tree is a method by which is a particular undesired system failure mode can be expressed in terms of component failure modes and operator actions. Fault tree analysis is a graphical tool to explore the causes of system level failures. Alright, so next we see for this is the example. This is the hazard table for our case study, which is the parameter we take is temperature, and then the temperature only have two division or guide word, which is high temperature and low temperature. So the causes of the high temperature we can see it here is the failure of cooling system. And then we from the causes we can make the consequences, which is if the temperature is too high, the enzyme activity will diminish and bacteria will be denatured. So the action required, we make the maintenance or make a predict check for the cooling system, and it assigned to engineering. This is also same to the low temperature, which is it has the causes, consequences, and action required. Alright, next. And then next is the parameter is the pressure. Pressure also has only two division guide word, which is high pressure and low pressure. For the causes of the high pressure, failure of control valve, and the low pressure is valve fully open. So the consequences, the failure of control valve can lead to the induced conformational changes in the cell membrane, cell morphology. It perturb biochemical reactions as well as the genetic mechanism of the bacteria, thus ensure the reduction in the microbial count. So the action required, we make a regular check or maintenance for the controller, and it is assigned to the engineer. Yeah, it goes same for the low pressure. It has the causes, consequence, and action required. So that's all for me. Thank you.
Hi and good evening. I'm Tanesh Vengadesh. So here I'm gonna present phase 2 of our poster, which is here. This is FTA, which is known as fault tree analysis. So from here, the top event of the fault tree is written at the top of the fault, and it's also indicated as a top event. There are two top events that occurs at a non-ideal pH, which is non-ideal temperature and non-ideal pressure. At non-ideal temperature, high pressure can cause failure of a cooling system. Thus, it can cause high pressure in the reactor. Meanwhile, low temperature can cause a rate of circulating cooling water to become high and failure of heating system. At the non-ideal pressure, high pressure can cause the failure of control valve and rise of temperature of temperature in the reactor. For low pressure, the valve will be fully open and cause pipeline leakage. Here is the table that we use to analyze FTA in phase 2. In the control valve, the failure rate per year is 0.60. The reliability is 0.594 and the probability R is 0.451. For thermometer temperature measurement, the failure rate is 0.027 and the reliability is 0.937 and probability is 0.027. For pressure measurement, the failure rate is 1.41, reliability is 0.244 and the probability is 0.756. So for failure of reactor piping, the failure rate is 0.1, reliability is 0.905 and probability is 0.095. As for controller, the failure rate is 0.29, reliability is 0.748 and probability is 0.252. For pH meter, the failure rate is 5.88, reliability is 0.028 and probability is 0.9972. As for the conclusion, from hazard table, we can obtain the causes, consequences, and action required to prevent the undesired action that can occur during the process. Through the FTA, the fault probabilities and single faults are being identified. Also to express a particular undesired system failure, we have to identify the top event, existing event, unallowed event, and also physical bounds. The routine inspection is to make sure that the large system valve will not open that can cause overflow. Thank you. That's all from me.